So a lot of times you are given 2 points, usually 2 points that are giving you the coordinates, the x's and the y's, and you're asked to find the slope. So we're going to go over that today a little bit. So anytime you have your 2 points trying to find the slope, remember that the first point is your x and the second point is your y. There are lots of different ways that you can do this. But I suggest putting the numbers in a table, an XY table. So your X's are -2 and 7, and your Y's are 0 and -16. Remember, the definition for slope, rise over run, is the same thing as the change in the Y's over or divided by the change in the X's. So we're going to start on the right-hand side. I like to tell my students to draw in a hump from 0 to -16. What happens to get from 0 to -16? Well, you're subtracting 16. So that goes on the top of your fraction for the change in the y's. Now let's do the same thing for the x's. If you're going from -2 on a number line, think about it, going all the way up to a +7, it takes 2 to get to 0 and then 7 more, so you're adding 9. Now, if this can be simplified into a whole number or a reduced fraction, you can do that. This one cannot, and so the slope for the first problem is -16 over 9, and it is okay that it's an improper fraction. The second one, again, make a table. X's and Y's. This is an X, this is a Y, this is an X, this is a Y. So my first point, if you want to do it this way, is -13, -13. And my next point is 12, 1. So I'm going to go from -13 to a +1. That means I'm going up 14. So my change in Y's is 14. And my change in X's, if I'm going all the way from -13, I have to go 13 to get to 0 and then 12 more. So that means I'm increasing by 25, +25. Again, that cannot be simplified. It cannot turn into a whole number. So the slope between those 2 points, the rise over run, would be 14 over 25, 14 25ths. Now this one, again, put it in a table. X's and Y's, 9, 16, and 9, -5. Now, I already noticed that something weird's happening because we have 2 9s in line. So I'm figuring that something might be up. But let's first do the change in Y's. So if I go from 16 all the way to -5, I'm dropping 21. So -21. Then, if I'm going from 9 to 9, I don't move at all. So that's a 0. Now this is a problem. Anytime you have 0 as a denominator only, 0 is on the bottom, that's undefined slope. And if you remember from the past lesson or lessons in the future, undefined is when you have a vertical line. We also learned that undefined means vertical lines, and it has an equation of x equals some number. Well, obviously, what does x equal every time? 9. So that's just a little bit of extra information for you to start recognizing when you see this business happening with the 9s or the x's repeating straight down. That's an undefined slope. We can't have a denominator of 0. So over here, look at this one. I'm going to make a table again. 12, -11, and 17, -11. And here we go again. Notice the y's are both -11. So for our change in y's over change in x's, from -11 to -11 is a 0. And then from 12 to 17 is a +5. Now we have a numerator on the top. So when you have a numerator on the top, that is okay. 0 divided by any number is simply 0. So the slope for this is 0. Now, if you remember from past lessons, when you have a slope of 0, you have a flat line like this, horizontal line. And the equation of those horizontal lines is y equals some number. Well, I'm assuming that since y equals negative 11 and a negative 11 here, when you graph that, the equation for that line, which we'll learn more about in coming days or coming lessons, is y equals negative 11. So again, we did a negative, a positive for the first two, an undefined and a 0. Be careful with those undefined and zeros. It is, this might help you remember, it is a no-no to have 0 on the bottom. Those are undefined slopes, vertical lines. It is okay to have a 0 on the top. That's just equal to 0, if that helps you remember. No and okay, undefined and 0.